because, first of all, NDK build is going to read your manifest. If debuggable is true, it's actually going to automatically remove optimization to help you debug your code. So it's going to try to help you out, but you should note that. You can override it if you wanted to, but by default, it's going to do that. And secondly, it's the only way to get permissions. Because just because you're running a native code doesn't mean you're going to actually be able to access the internet, using the internal socket stuff. You're still going to actually have to have permissions. All that stuff is still applied. So it's still important. A lot of people say, well, now that I'm using native code, can I do this? The answer is, you might be able to, but you're first going to have to declare to your manager. So, calling native code, how do we do it? I'm using the Plasma example, which is one of the ones that ships with the NDK. Talk about this. So, we declare a function as being native in the class file. In this case, we run under Plasma, we have 2 parameters. And then we run Java set JNI. And it generates the following header, which contains return value, the class name, method name, JNI context, the class object, and parameters. And, but anyway, and then you build it with NDK build, and then you can call the function. And you can call all this code just as easily. So you build your class file, and then what you can do is it's called Java P to actually get the signatures for your class file. The signatures in Java will look something like this. And that means that it takes a Boolean parameter and returns a void. Internal syntax. The cool thing is that Java P will actually just print out the signatures for all the functions and built in the jar file for you. So it's pretty cool. And then when you get reference to a class of size, you can call the method using one of the internal functions and the JNI environment passed through. So it's pretty straightforward to do. Next. One of the things we don't actually support is using Eclipse together with the NDK, but you actually can. And what you actually can do is, after you've gotten it installed, you actually can convert your project to a C and C++ project. And this creates a hybrid project that actually looks at the C code and the Java code together. It's not quite perfect, but it actually works pretty well. And then what you do is you actually set the configure build tab on the C build and set the build command to NDK build. And so that actually will get you pretty close to being integrated. It's not perfect, but it's close. So debugging. So everyone was excited about the announcement of the fact that Android 2.2 supported user mode debugging in NDK. But there is a limitation. It only works with the main application thread. So if you're writing a multi-threaded application, it's actually not going to do anything that we're supporting probably. So unfortunately, we still are going to have other ways of debugging. And there's no built-in integration with Eclipse either. Now, this doesn't mean it's impossible to integrate with Eclipse. GDDDE server supports a machine interface, and you actually can set it up so that it will integrate with Eclipse, but it does not actually come pre-configured that way. So what do? Well, you take advantage of setting breakpoints in your JNI code, and of course, lots of log functions. And okay, let's talk about asset management. So a lot of people are saying, what is the best way, the most compatible way to get to assets from native code? Because everyone, you're distributing a game, and you've got some options for how you distribute your assets. One is you can compile it into your code. This is really, really bad. And the reason why it's really bad is that under Froyo, anything that's compiled into a library cannot be installed on the SD card. So if you compile all of your assets into your code, all of a sudden your application is basically, even if you try to install it on the SD card, it's actually not going to do anything because all of your assets are still going to sit inside of the internal flash. And so you don't want to do that. You don't want to use calls that are undocumented and unsupported because there's a good chance they're going to break. There's a lot of work that's going around native code, and there's a very good chance that if you take advantage of some of the internal structures that it's not going to work in future versions of Android. However, one thing that is not guaranteed to stay the same, but is probably going to continue to work, and again, nothing is guaranteed here, is you can actually use the same method you use in Java. So you actually get the asset file descriptor for your asset, get the offset and the length. And then you can actually get the ADK file name using this source dir thing. And then you can actually open the ADK file from native code, have the offset and the length, directly read your asset in. So that's actually a pretty good, relatively supported technique. It's about as good as you can get today. resources. Now, a lot of people say, well, I still want to be able to do things like internationalize my application, even though I'm doing a lot of stuff in the NDK. Well, you can't. And in fact, all you have to do is just add a string. Then you compile it, you compile the resources, and then you can run Java H on your .r file. Now, your .r file actually contains a bunch of internal classes. And so you're going to end up with a bunch of header files, each one of the types. But those files will contain defined that contain the resource IDs for all of your strings or assets. You can actually directly then make calls using JNI to fetch the strings. And you'll actually get all the right values. So that's pretty cool. And if you want to, you can even integrate it with Eclipse. And so I played around with this today. And so basically, you got, in this case, I just created a new builder. And the builder is actually just going to call this JNI, this JNI call on whenever one of the gen files changes. So it's pretty straightforward, and that way you'll always be relatively fresh. It's not perfect, but it's there are worse days. All right, so let's talk a little bit about what an NDK app looks like. Now this is from a 4K demo that was done at a finished party, and so now it's been ported to OpenGLES and it's been put onto Android, and now it's about 400K instead of 4, and it has half the geometry, but still a really good example. What does this look like? This is a San Angeles demo. So once again, you've got the Android framework, which contains an activity. Now the activity contains one view in the view height group, which is the GL surface view. And the GL surface view, along with a renderer that's associated with it, ends up calling into this native code, which actually does all the OpenGL. And one of the cool things about using OpenGL in native code is that the context is shared between native code and the Dalvik code. So you can create setups, do everything in the context, even make calls within Dalvik, and then you can actually go and do rendering and stuff that actually requires a lot more CPU horsepower in the NDK. So, what does this look like? Well, if you ever look at this code, it's pretty simple. Renderer looks like this. You get surface created, changed, and non-draw frames, and we simply patch call straight to these native functions, which is like this. And then within the native code, we're actually doing something smart because we know that on compressed handsets, we're not going to get a consistent frame count. So we're actually calculating our time offset, passing that back into the renderer so that we actually end up just getting more frames on a faster handset. And something everything has to do. Believe it or not, there have been some things that are shipped on Android that run too fast on fast phones. So this is another example. Now, Chris Pruitt has been working on a 3D game demo that's built on top of O3D, which he ported from Chromium to the NDK. These are very, very big projects. And it's still under heavy development, approximately what it looks like. You've got some zombies running around, you've got a guy who's running away from them right now. That's pretty much all he does. With joystick controls on the touchscreen. And what does this look like? Well, this is a more interesting app because it actually has a lot of stuff in Dalvik. The game logic is actually completely contained inside of Dalvik, but the rendering is actually contained inside of C++. And it also takes advantage of a few other things within Dalvik, like a web server and sound tool. And again, this is nice because all of this stuff is being run from Dalvik. It's very, very easy. And again, he's just moving things around and calling it the O3D engine in terms of rendering. This is not a bad way of dealing with game design. So let's talk about some common problems. Now, we're going to focus a little bit on gaming here because it's one of the primary things the NDK is used for, and also it's part of what I do. So gaming is easy for to do, I'm sorry, but I think it's pretty cool. So when my OpenGL application returns to the pod state, it crashes. So GL Surface View tries to be a really, really good citizen, and it nukes your GL context as soon as you go into on pause, which means you're going to have to reload your textures. Now, if you don't use GL Surface View, you can actually be a little smarter. You can actually look at the last call, which is going to have an error, and see if the context is lost. And that way you can actually make your app perform a lot better. So you can make it so it comes back to a pause state a lot more quickly if you happen to be using something else that ends up using the OpenGL context.